To differentiate u, say u prime is 2x.
Sir,
Yeah?
your voice is off.
All right. So, to differentiate, after you have these derivatives, then you say y prime is then going to be u prime v minus z prime u over v squared. So u prime is 2x. V is cos 2x plus 3 minus it will become plus 2 sine 2x plus 3 multiplied by x squared plus 1. Everything divided by cos squared 2x plus 3. So it's too easy.
Sir,
Yeah? You don't need too much, yeah?
yes. How come B prime is that?
Easy chain. Chain says you differentiate the inside of the function and then differentiate the function itself.
I'm a bit lost. Where have you gotten -2? Where is sign there?
So the derivative of cos u is negative sine u multiplied by u prime. Yeah, of cos 2x plus 3. So u is 2x plus 3. So u prime is 2. So that the derivative of cos itself is negative sine 2x plus 3. When differentiate the u, you get 2. You can write this as negative 2 sine 2x plus 3. That is where it comes from. I'm just saying that it's nice. But find the equation of the tangent after the curve x squared plus xy plus y squared plus 1 at the point 1, 0. So x squared, for you to get the equation of the tangent, you need the gradient. The gradient is dy dx evaluated at the point 1, 0. So let's find dy dx. To find dy dx of this function, this equation is supposed to be equal to 0 here. Not on the equation. So you differentiate x squared, it gives us 2x. When x times y, when differentiating x, you keep y as a constant. So the derivative of x is 1, then you multiply by y, plus the derivative of y is 1 dy dx, because it's y, then you multiply by x. So this time, we bring it here. So we have plus y, derivative of x, then plus x, derivative of y, and because it's y, we put dy dx. Plus, you differentiate y squared, you get 2y. And because of the y, you write 1 dx is equal to 0. Then take this to the other side. As you factorize the dx into square 1. So you have y dx, and then what remains is x plus 2y, which is equal to negative 1 minus 2x. Divide by x plus 2y and divide by x plus 2y, so that we get dy dx is equal to negative 1 minus 2x over x plus 2y. And then evaluate this circle at 1, 0. Meaning that m is going to be y is 0 minus 2 x is 1 over x is 1 plus 2 by 0, giving us negative 2 as the value of the tangent line. So the tangent line itself, the tangent line is going to be y is equal to mx plus c, implying that when y is 0 and m is 2, x will be 1 and c. So c is equal to 2. Therefore, y will be equal to negative 2x plus 2. That's how we find the equation of y.
Excuse me, sir.
Okay.
I'm confused. There when there's 2x plus y, where is that y coming from?
2x plus y. Two x plus y. Which 2x plus y? This one.
Yes, sir.
2x is the derivative of x. So I differentiate in this one. I differentiate in this.
So the xy, why wasn't it x dy dx?
Yeah.
But where is that the other y coming
When you have x, y, they are differentiating. You treat it as a product. In this product, you let u dx, v dy. Differentiate u, you get 1. Differentiate v, you get 1. But because it's y, you multiply it by dy dx. And then
from?
find u
Oh,
prime
okay,
v plus v prime v.
But is that x? There's 2x plus y. What about that other y?
This is the y now that we're explaining here. But when you say u prime v, u prime is 1, v is y. So 1 times y, you get y. Plus v prime, dy dx, u is x, so you get x, dy dx. So this y here is this one. So part 2, find the stationary point. Find the stationary point of f of x is equal to x power 4 minus 8x squared, and determine their net. Determine their net. Hence, part 3, sketch the graph of the curve y is equal to x4 minus 8x squared, indicating or intersects. Two plus 4 marks, 6 marks altogether out of 20. The other 4, as well, we are finding those limits. And then the other 4, where we are finding the tangent line. So it is part 1, the stationary points. You get a function f of x, x4 minus 8x squared. Then differentiate it. So you get 4x power 3 minus 16x. Then you get it to 0. So you have 4x, and then you remain with x squared minus 4 is equal to 0. So x is 0, or x squared minus 4 is 0. So that x is 2, or x is negative 2. So these x0, x2, x negative 2 are the critical numbers. So if you take 0, you take it in f. Excuse, you find the value of y that responds to 0. 0 power 4 minus 8, 0 squared will give us 0. So we have a point 0, 0. In fact, I can put in this point here, 0, 0, 1. Pick 2, take it in the original function, and get it the corresponding value, 2 power 4 minus 8, 2 squared. 2 power 4 is 16, minus 4 times 8 is 32. So we'll get negative 16. So we have a point 2, negative 16. And then negative 2, we get f of negative 2. We have negative 2 power 4 minus 8, negative 2 squared is equal to negative 16. So you get negative 16. So we have found these corresponding y coordinates because the question says find the points. A point is x, y. That's why we have found those points here. And determine their nature. Determine the nature, you come back to the function and differentiate it again. So the first derivative, we differentiate it again. You get 4x squared minus 16. And then start picking the values of x and take in the second derivative. You get 4 by 0 minus 16, which is negative 16, which is less than 0. Because the second derivative is less than 0, this point here, its nature is maximum. And we say it's local maximum. Then we come to 2. Take it in the second derivative. We have 4, 2 squared minus 16. This is going to be 4 times 12. That's 48 minus 16 is equal to positive 32, greater than 0. So this is local minima. Then get negative 2. We have 4. Negative 2 squared minus 16. We get 48 minus 16, again 32, greater than 0. So another local minima. We have determined the nature. Hence, sketch the graph indicating the x and y intercept. We already have its turning points. All we need is the x-intercepts. The x-intercept, this equation f of x, get it to 0. We factor out x squared, we remain with x squared minus 8. So we are saying x is 0. When you equate this guy to 0, of course, x is 0, and also x squared minus 8 is 0. This is giving us x is plus or minus equals to the root of 8. And then the y-intercept, we take 0 in the original question, we get 0. So we can sketch six marks. The y-intercept, negative root 8, positive root 8, and 0. The turning point, 0, 0 is 0, minimum. And then 2, the negative 2, negative 16. We need 0, minimum, 0, 0, 0, maximum. And then 2, negative 16 again. So this guy is coming like this. Hit here, go up, hit there, and down, and go up. So then, after seeing that, when you say this is not recommended, this is not recommended, it becomes the minimum point. This is the minimum point and the other minimum point because there's nothing below it. This one remains local because it is maximum here, but there are numbers that are bigger than it on the sides. That's the language we use in mathematics. To finish up this paper, we go to question 7 and look at how nice it is. Question 7. A. Let A be equal to matrix 1, 2, 0. Let B be equal to matrix 1, negative 1, 2. Find 1. A, B, transpose. For you to find A, B transpose, you first need to write down the order of the transpose. So for you to find the transpose, you first need to find the AB itself. So AB is 1, 2, 0, multiplied by 1, negative 1, 2. We say that matrix multiplication is possible if this guy is m by n, and the next matrix to multiply with must be n by you don't care. So let's see where these are the number of columns in the first matrix, and these are the number of rows in this other matrix. So how many number of, so here, as you can see, we have a 3 by 1 multiplied by a 1 by 3. So it will work. And the order is going to be 3 by 3. So we have 1 times 1, we get 1, the first entry. 1 times -1, we get -1, and 1 by 2, we get 2. Then 2 by 1, 2, 2 by -1, -2, 2 by 2, we get 4, and then we get 0, 0, 0. And then we are saying you want the transpose of this guy. So the transpose, AB transpose, therefore, is equal to 1, -1, 2, 2, -2, 4, 0, 0, 0. The transpose is you switch what were rows now become columns. That is what we call the transpose. And the order of this matrix is 3 by 3. The order is obtained from there, 3 by 3. You get 3 marks. Then 2, find BA. BA is 1, -1, 2, multiplied by A, 1, 2, 0. To check if you can multiply this, you want to have m by n. This guy can only be multiplied by a matrix which has n by whatever is here, you don't care. So let's see, this is a 1 by 3. And the other one is a 3 by 1. So you can multiply. And the order will be 1 by 1. So it will be a scalar. So 1 times 1, you get 1 plus -1 plus by 2, -2 plus 2 by 0, you get 0. This is giving us -1 in the matrix. We are done.
So,
Get to Marcelo.
when multiplying a matrix, don't we say row by column?
That's what we do. That's what
But
we have
BA
done.
isn't it 1 by 3?
Row by column. Is it what you said? So we have multiplied the row by the column.
Sir, 7A, why the what's this? After multiplying, why one not adding like 1 plus -1 plus that, or you just need to leave it in that way, or what?
We're adding except how do you add? If I give you that x is equal to 2, then I say add x. Like we wanted to add, but you only had single digits. How do you add? Because it's row by column. So the row is 1, the column is 1. So 1 times 1, You get 1. You're done. There's not any other entry in that row.
Oh, okay, I get the point.
Yeah, good. So my assumptions are that we are revising. I hope we are revising. B, A is equal to 2, 0, 1. So when there's a question that you've never seen before, not question. When there's a concept that you've never heard before, you indicate that that concept is new. So that I stop revising, I teach that concept. Thank you. Find A inverse. So it said, find the inverse, we first need to find the determinant of A. Find determinant A, we choose the first row. Annie, what do you mean by the previous questions?
So for integration.
What have I done?
So confusing, a bit confusing.
Yeah. All right. Okay. When we find other integration questions, I'll teach you, don't worry. So we use the first row. We pick 2 and then cancel that row where 2 belongs in the column. In the matrix that remains, we get the determinant. So we multiply 1 by 3, we get 3, minus 1 by 1, we get 1. And then the second entry is 0, so we don't do anything there. We jump to 1, cancel the row and the column, and remain in the matrix 1 by 1, we get 1, minus 1 by 2, we get 2. So the determinant is 2 by 2, which is 4, minus 1, which is equal to 3. This is the determinant. And so we now want to find the cofactor matrix of A. So we can rewrite the A since I have made it updated. So to find the cofactor matrix of A, remember that we rely on the invisible signs, plus, minus, plus, minus, plus, minus, plus, minus, plus. And then we go to 2 and don't do anything on 2. We just cancel each row and each column. And then get the determinant of the remaining matrix. So that is 3 minus 1, which is 2. So we bring 2 here. We go to 0, cancel each column and each row, and get the determinant of the remaining matrix. So 1 by 3, that is 3 minus 2, we get 1. And then we got the third number, cancel each column and each row. Then we have 1 minus 2, which is negative 1. And then come to this position now, cut this row and that column. Then we have 0 minus 1, that is negative 1. And then cancel this column and this row. Then you have 2 by 3, that is 6 minus 2, that is 4. And then cut this row and cut that column and the row. Then you have 2 minus 0, that is 2. Then the third, we remove this, and remove this, we get 0 minus 1, that's -1. And then we remove the second and the third, we get 2 minus 1, that is 1. And then you remove the third, you get 2 minus 0, that's 2. This can be written as 2, -1, -1, 1, 4, -2, -1, -1, plus 2. And so we find the adjoint of A. The adjoint of A is the transpose of this matrix, of the cofactor matrix. So you get 2, -1, -1, 1, 4, -2, -1, -1, 2. And then now get the inverse. So we say A inverse is equal to 1 over determinant A, which is a 3, multiplied by adjoint A. And done. That is A inverse. Then they say hence or otherwise, solve. This was 1. 2, say hence or otherwise solve 2x plus z is equal to 1. X plus y plus z is equal to 4. 2x plus y plus 3z is equal to 10. So to solve this one, you first write it as a matrix of coefficients: 2, 0 for y, 1 for z, and then 1, 1, 1, then 2, 1, 3, multiplied by x, y, z is equal to 1, 4, 10. Now if you look at this matrix here, this matrix is matrix A, whose inverse we have found. So to find these variables, it becomes an easy thing. You just say this variable will be found by multiplying the inverse of A by B, where we call this B. And this happens an easy way. You keep 1 over 3, which is the inverse of A, 2, 1, -1, -1, 4, -1, -1, 2, 2. This is -2, and then multiply by 1, 4, 10. This multiplication here is this matrix. You can keep 1 over 3 in the meantime, then 2 by 1, you get 2 plus 4 minus 10. And then you get -1 plus 16 minus 10. Then you get -1 minus 8 plus 20. This is 1 over 3. Open. 6 minus 10, that is 4. And -11 plus 16, that is 5. And then -9 plus 20, that is 11. So x is equal to 4 over 3. Y is equal to 5 over 3. Z is equal to 11 over 3. That's how you find it using inverse. So when you find that the matrix that you form as A is the matrix that you are dealing with up there, there's no need of going for to Cramer's law. You just hammer it here. You just multiply that inverse by the solution matrix. The values you get are the values of x, y, and z. So that we end here today. As you do Region 7 C part 2. C part 1 is not part of the course so far?
Sir,
You know?
yes, sir. So when arranging for X, is it wrong to like, since you put it in the row, in the column, sorry, is it wrong to put it in the row? Since
It's
X
wrong.
is there,
It's
like
wrong.
you represented it.
You put it in the column. Put it in the bottom of the plan. So when it cuts, good night. Before it cuts, you can be talking.
Sir, I've got a question. I noticed when you use there was this error when you are finding the determinant, you are getting a 3, but I used the